live now. Now it's live.
There it is.
Yeah, wait.
Can you hear the music in the background? Because I have to play this off of one of the speakers. Can you hear the music in the background? Because I have to play this. Oh, that is weird.
Lower the volume on your YouTube feed.
It says it's live, but it's not live. It's just 5 minutes. It's 5 seconds. That's just. Yo, okay, Midnight Madada. Who are you?
It's Elizabeth.
I just realized that I don't.
Oh, that's a
be on
bot.
the Livestream, do I?
A bot.
Talking through this.
There's a bot.
Because I have to listen through the speaker on my computer, so.
Alright.
Oh, so you would have to listen to.
Yeah, because
Wait.
I'm hearing my voice through the speaker and through this at the same. Well, not through this, so I'm hearing my voice rebound, and it's very confusing to me. So, would it work if I just turned off the speaker and looked off of like from hearing you guys on here and then looking on this?
Yeah.
Okay. There we go.
I'm also using that the mic headset that I told you about that was like really sophisticated.
Uh-huh.
Yeah, it's I didn't expect it to work because usually it doesn't.
Oh, good.
Yeah, it works usually on the Xbox controllers, so I'm surprised.
Alright.
You want to do the equation that I'm on?
Yeah, I do. I just I want to let people know that I had to restart the live stream.
Yeah, like it's posted a 5-second live stream.
Can't you give nicknames to people on the chat? Because you can rename my person. You can give them a nickname to like Elizabeth or something.
Yeah.
Now I know who you are now. I know your first name. And I think I know your last name.
Don't say it.
Yeah, please don't.
We have a question. Do you wear glasses?
Yes.
Okay, Jonathan.
That's it. No more information.
You used to play with bugs a lot?
I know who you are. You don't have to give me any more details. Alright.
Okay. Elizabeth, can you tell me the unique ID number for your question?
0254 on the level 3 exponential.
Okay. I'm getting into it right now.
Is it showing on the live chat?
No, I won't. You will not see your name. Okay. I'll write it. I've got a separate computer that I look this stuff up on.
Having fun?
Yeah. Oh, what the heck?
Wow, you got a lot of this done. Okay. Oh, all the assignments, you got them done. Up until the current ones. That's good. You're all caught up. So this is 254?
0254.
All right. Let's see how live this live stream is.
I've done
Oh, good.
Rule 1 and level 1 and level 2, but I haven't done level 3 yet, and then I'm gonna probably go through the other ones along with you guys.
Okay. Perfect. Well, let me write it down, and we'll get a new note started here so I don't blow my memory up. We'll call this Solving Exponentials live stream. Once we do a couple of these with Elizabeth, I want to I've got an idea. Okay, so while Zach is working on getting this update done to DeltaMath so I can give you guys the same exact problems, until that time though, what I can do is we can move through the same topics, so we're all on the same topic at the same time, and that might actually help a lot. Okay, so Here is Elizabeth's problem.
Okay.
Elizabeth, tell me if the size is too small or too big. This is going to be number 254.
Okay. This is the correct problem?
Yep.
Alright, man, so he's coming here. Okay.
All right, so express the following fraction in simplest form using only positive exponents. So here we go. We have 20 t to the negative sixth power. Oh, good. It's not lagging at all. I like that.
Oh.
A to the negative third power all over
See, the other two are a lot easier.
yeah, no worries. We'll get you through it. 4
Some of mine by myself.
good. T to the negative third, a to a squared. Close parentheses. Negative 2. Okay. So, Elizabeth, we're going to take this one step at a time. And we are going to start by placing a 1 in the exponent position of the 4 in the denominator, so that we know what we're going to be multiplying each of our exponents by. We're going to apply the power rule and multiply this external negative 2 exponent and multiply it to all the exponents for the things inside the parentheses.
Oh, that's simple.
And I'll just make these distribution lines here. And what I'll do is rewrite the equation. I'm going to leave the top by itself. 20 t to the negative sixth, a to the negative third, all over, and this time I'll now have no parentheses, but I'll have 4 cubed, 4 to the third power, t, and now we have negative 3 times negative 2, which is positive 6, and then a to the 2 times negative 2, which is negative 4. Okay? Now, Elizabeth, over here in side work, I want to let you know something. 1 over a to the negative 4 is equal to a to the 4 over 1. Okay. Similarly, t to the negative 6th over 1 is equal to 1 over t to the 6th. All right. A to the negative third is equal to 1 over a to the third. So this is some of the things we're going to be doing in the next step. If I see a negative exponent in the numerator, I'm going to move that down into the denominator and change the exponent. If I see a negative exponent in the denominator, I'll change the sign of the exponent and move it into the numerator. And those are all implementations of something called the negative exponent rule. The other thing I'm going to do is section off the numbers. Okay, we're just going to leave those alone for a minute, and we'll come back to them in a second.
So you got the
Come on.
positive 3 exponent from 1 to negative 2, so it's not going to be a negative 3?
You know what? I'm an idiot. It is a negative 2. And I'm so glad you caught that. My brain was just not functioning, and I added them, and I even added them incorrectly. I just wasn't thinking. Sorry. Okay. Good catch. So let me leave these numbers alone for a second. I've got 20 over 4 to the negative 2 power. I'll just leave that multiplied off by itself. And now I'm going to notice that both of my exponents of the variables in the numerator are negative. So they're going to go down into the denominator position, and their signs will change to positive, okay? So let me rewrite what's down there already, and I'll kind of group the letters together. So I have t to the 6th power times t to the 6th power times a to the 4th power times a to the 3rd power. And just to review, guys, the reason I'm able to reorder those variables is because multiplication is an associative and commutative mathematical function, which means I could rearrange any terms that are being multiplied just to group them. Makes it easier to work with. Now, in the numerator, all that's left is a 1. Okay? Yep.
Oh, okay. I think I see what you did.
So,
And it put them all into positive instead of negative. Doing that.
yeah, I'll show you a map, okay? And then I'll erase it. So, this guy right here, this t to the negative 6th, he is right here. He didn't go anywhere. There he is right there. And this a to the negative 3rd, he is hanging out right here as what is essentially 1 over a to the 3rd. Uh-oh. There we go. You see where they went?
Yeah, I see where they went, but they're not negatives.
That's right. See, when they go into the denominator, their sign changes. This, I'm going to write down the negative exponent rule for you, okay? Here's the negative exponent rule. And this is good review for anyone watching. Because I think this is probably something that confuses a lot of people. So, if I have x to the negative a, that is equal to 1 over x to the a.
I'm not sure if they can. Sorry about that.
No worries. Similarly, if I have 1 over x to the negative a, that's equal to x to the a over 1. The thing that changes here is I'm just moving the whole thing down into the denominator, and I'm changing the sign to positive. And then here, in this 1 over x to the negative a example, I move the variable and its exponent into the numerator, and I change its sign from negative to positive. So the effect of going, if you're in the numerator and you have a negative exponent, you can get rid of your negative exponent by jumping down into the denominator. And vice versa, if you're in the denominator with a negative exponent, you can just hop up into the numerator and become positive exponent.
Okay.
So when you see me doing all this kind of jujitsu with the numbers, it's because, and when the letters, kind of throwing them around. Like, let me show you what I'm going to do next, okay? You see this negative 2 that's associated with that 4?
Yeah.
That means that this guy can hop upstairs here and become 4 squared up in the numerator, and then he's just gone from the denominator. Because 1 over 4 to the negative 2 power is equal to 4 squared, which we know is 16. Okay, so this is kind of weird, but 1 over 4 to the negative 2 power is equal to 16. That's wild, right?
Because 4 squared is 6.
4 squared is 16.
Oh man.
Isn't that crazy?
How does the 4 on the bottom become a positive?
Ah, so let me erase this stuff so you can see it happen again. So we have 4 to the negative 2 power, right? Well, who's ever heard of a negative power?
No, not that. See,
Oh.
A is negative 4 on the other equation. I've noticed that one was a positive 4 too. So I was wondering how the negative on the bottom became a positive 4. A little confusing.
Oh, yes. You know what should have happened here is my pen didn't capture this symbol.
Oh, it is.
Okay, so he didn't change yet, all right? He's still...
Oh, I think live stream's loading.
Uh-oh.
Yeah, my internet's glitchy.
No, it's not your internet. It's mine.
Oh, is it?
Yes. Hang on a second. Oh, no.
Oh.
Please don't do this to me tonight, internet. Trying to help some kid.
I mean, I know there's a season 4 coming, I'm pretty sure,
Wait.
but
What? Oh, now.
Cool.
they do have good
Looks
bandwidth.
like.
But...
What the what? Okay, this says this video. This says solving exponential delta math homework help live stream live to 22 minutes.
Yeah, it'll be okay. Hang on.
We're already at 15 minutes.
Well, the live stream's been going that long. Okay.
Oh, there you go. There you go. I'm back on it.
Right.
Never mind. Oh my god.
Now, you see it now?
Yeah, it's working now.
Okay, I killed a bunch of background processes, so hopefully it'll work. Let me kill one more process just in case.
I still don't have a live video.
There's also I'm forgetting what it's called, but if you like left click on the background of your screen, it's like management or something.
Yeah.
Storage management. Doesn't work on this computer, I don't think. Oh, did I just close out everything?
No, you're okay. Hang on. I was going to show. Otherwise, I would have shown student data.
I'm back.
Oh no, I think it just closed out. I think I just accidentally closed out DeltaMath and everything.
Oh, okay. But can you still see the stream?
I just got back on it. I accidentally clicked the X on instead of like the minimize, I clicked the X on my tabs and everything, so it just
okay.
I got back on it too.
So do you see, let's wait for Elizabeth to see when she can see the stream.
Okay. It's blurry, but I can see it.
It is blurry?
Yeah, but that might be just my settings because it says auto 144p, so let me try and set it higher.
Yeah,
I can see it now, so my settings they automatically zip.
Okay. I gotcha.
Very bad computer.
Okay, so now let's address this issue of the a to the negative 4 and the 4. Yes, it is, and the 4 to the negative 2.
Yeah.
Okay.
We solved the 4 to the negative 2, didn't we?
Well, I erased it.
No,
Yeah.
Oh, okay.
No. Oh, hold on.
So what I'm going to do now is kind of show you in real time how I move. No worries. How I move the numbers upstairs from downstairs. Okay.
Oh,
So the 4 to the negative 2 becomes 4 squared. And the a to the negative 4 becomes a to the 4th. You see that?
Yeah.
Okay. So let me show the next step here. So this equals 20 times 16 times a to the 4th over, and now we're going to apply the product rule to do t to the 6th power times t to the 6th power. The product rule says that if we have x to the a times x to the b, we add the exponent. So we have x to the a plus b. That's the product rule.
What the? Oh, wow. Dang it. whatever. There's just
So
one
it
more
would
step
be
I'm
a
missing,
plus.
and I can't.
Okay, so it'd be 12.
That's right. It would be t to the 12th power in the denominator
I got it right.
times a to the 3rd power. And notice where I wrote that a to the 3rd power way over by the other, underneath the a to the 4th power. Okay.
And then the t to the 12th power is right underneath the 20.
Yeah, the t to the 12th power doesn't really matter where you put it.
But the A one does?
Well, just for our visual, okay, because now we're going to apply the quotient rule. Okay, here's what the quotient rule says. The quotient rule says if I have a to the 4th over a to the 3rd, then I subtract the exponents. I'll have a to the 4 minus 3. So that would be a to the 1st, or just a.
Okay.
Okay. So let me erase this side work here. Get the problem nice and clean for us. So our next step here is to say, okay, we've got 20 times 16 times a all over t to the 12th. And now it's just a matter of saying, well, 20 times 16 is 320, right?
Yes.
Yeah. Because 16 times 2 is 32, so 16 times 20 is 320. So that means we have 320a all over t to the 12th power.
Okay.
And that is your simplified answer. So we'll put that
To Desmos? I mean Delta.
delta. Yep.
So 320A
Mm-hmm.
over the power. I was right.
Yay.
Okay.
Now let's zoom out and look at the work. It's kind of a crazy, I mean, it's hard to believe that we started here with this mess and that we ended up with this kind of more simple looking, and who knew that you'd end up with a 320? You know,
Yeah.
it's, to me, these are so much fun. Like, I don't know that there's anything more fun than playing with this, because it's like somebody's put together a puzzle and you're trying to undo it, you know? So I have fun with those. All right, Jonathan, you up, man?
What's the next one we're doing?
Okay, I got. I mean, well, you don't have to do it 'cause it's my problem, but if you want to.
Well, it still helps me out.
I got.
Well, here's what I want to do, okay? What I want to do is I want you to tell me what problem set you're working on and what section you're on. What section are you working on from that problem set? Because then Elizabeth and anyone else listening can go to that problem set and type on their computer on DeltaMath, and then it will probably look identical to theirs, except the numbers and stuff will be different.
Yeah.
I got. Okay, my problem is open parentheses.
Well, hold on. Tell me the unique ID. Tell me the unique ID.
Okay.
And under which,
02,
like, is it
I can.
exponential equation,
Yeah.
or-
Are you under solving exponentials, Jonathan?
oh no. Oh no, I was doing exponentials. Oh my god.
Hang on, let me find you, okay? I'll be able to find out exactly where you're at. So you're under solving. You're doing solving exponentials. You're on level 3.
Oh,
This is number 292, right?
Yes.
Okay. Elizabeth, hop out of your existing unit and hop into solving exponentials level 3.
Okay, level 3.
Yeah.
All right, and my unique ID is 255, so it's not that very different from his, I don't think.
Yeah. I'm going to get both of yours up so I can teach both of you at the same time.
That might help to have two different like examples.
Yeah. And it'll be a good challenge for me because I'll have to solve 2 equations simultaneously, which is fun. That's how, Jonathan, that's how I do when we did the factors and we set them equal to 0. I like to solve them row by row where I'm doing multiple solutions at once. Okay. What's your number, Elizabeth?
255.
255. Okay. Perfect. Okay, so let me get it written down and we'll write both of y'all's stuff down here. So let me keep Elizabeth in the same line as she's in. So this is going to be Elizabeth's problem number 255.
Estimation wise, how long do you think is live stream?
Well, it's as long as you want to be here. I'm going to be here till 9 because you got kids that come in at all different times. You can come and go anytime you want, okay? Don't feel like you have to stick around for the whole thing. If you get some help and you start to understand, you can just leave and go for it. Go for it on your own. And if you need any more help, you're free to come back.
Hi and thank you. That's what I'm.
So negative 0.2 equals 1.075 raised to the power of x minus 3. What?
Well, this doesn't look as difficult.
Oh, I guess, yeah, it's not. It's like a completely different topic. So that's Elizabeth's problem. Now, Jonathan's problem is number 292. This is Jonathan. Okay, and we've got 2,600 equals 3,710.
Sometimes I'd be called Jonathan.
Open parentheses 0.99 close parentheses, and then in the exponent it's 0.37x minus 1. Oh boy.
It looks ridiculous, man.
He'll be okay. So let me just no, they're actually both solved the same way, but Jonathan's just has bigger numbers. I mean, we're going to use the calculator to actually compute the logarithms, so it really doesn't matter how big the numbers are. Okay, so let me start with Elizabeth and give you the first step here. The very first thing that we have to do is add 3 to both sides.
Okay, that makes sense. So would that
Okay.
be? Oh, I don't. Negative point plus.
Can I give you a little piece of advice? Okay, write it like this. 30 tenths minus 2 tenths.
What the
do it as fractions, okay?
All right.
And see, then you got 28 tenths.
Yeah.
All right. So you have 28 over 10 equals 1.075 raised to the power of x minus 3. Jonathan, do you mind if I just finish this problem real quick?
I don't mind.
You don't mind? Okay. So, Elizabeth, now our goal is to get the x minus 3 to come out of the exponent position and sit down on the same level as the 1.075. Do you remember how to do that?
Yeah. We would multiply. Is it dividing?
This is
Oh, I know what the ln thing is.
Yep, that's right.
Yeah.
This is the power rule. So I'm going to take the natural logarithm of both sides. And I write it like that because if I were to write on the right side of the equation, if I wrote the ln to the left, it would be covering up the equal sign. So I write it like that first. And then when I rewrite my work, I fix it. So now we have ln of, can we simplify 28 over 10? If we divide by 2, I can get 14 fifths.
Yeah.
So the ln of 14 fifths equals, and now I have open parentheses x minus 3, close parentheses, times the natural logarithm of 1.075.
Oh, 1.0. Okay, I see now.
Okay. Now, you're 2 steps away from being done. What you have to do first is reverse this multiplication that I just put a red dot on. It's coming up. There we go. How do I reverse that?
Divide.
Okay. So I'm going to divide both sides by the natural log of 1.075. And I can now cancel out the natural log of 1.075 on the right side. Okay. And so now we're going to be 1 step away from being done. So there is a lot of rewriting with this. We're going to write ln of 14 fifths over ln of 1.075. And that's equal to x minus 3.
Okay.
Now I've got 1 step to get x by itself. What should I do?
You gotta get rid of x minus. Oh, do you add 3?
You do. So we'll add 3 to both sides of the equation. Okay?
Okay.
And that gets rid of the 3 on the right. So now what I've got is I've got x equals, and then I've got this ugly thing over here. All right? So what we're going to do now is boot up the calculator. Did you have one, right?
Yeah, you gave me.
Good. So you're going to go to the calculator and go ahead and clear the memory. Second plus 712.
Yeah.
And then go to the home screen.
Okay.
And what we're going to do is type 3 plus, and then we're going to hit alpha, y equals, and then enter. Because I'm going to enter this fraction now. I'm going to now hit the LN key, which is right next to the 4. And then I've got a 14/5, so that's another fraction. So I have to create another fraction by hitting alpha, y equals, and enter. Okay, so this is starting to look structurally like the one that I have written down to the left of the calculator there. So there I'm just going to put 14 over 5. And then I'll close out those parentheses. And then downstairs here, I'll hit LN and just type 1.075. And then close those parentheses. Does yours look like mine?
Yes, it does.
Oh, no. No, it's not. It's just buffering.
It's a bit delayed.
No, it's buffering, completely buffering. Let's give it a second. Oh, good. Now it's moving. Okay. Whew. Let's let it catch up now.
I wonder why more people don't get on this thing. It's very bad.
Well, you know, you can kind of understand it if
There's 6 watching.
if we were going to experience these kinds of delays, I could understand why people wouldn't want to watch it. So I think in the future I'll do these from school. You know, let me tell you why. I mean, for me, it's like I'm at that building all day, just like you, and I want to get out of there.
Yeah.
So that's why I really don't want to be at the school. It's just more comfortable here. But I'm going to do it at the school because I mean these connection issues are impossible, and we're not going to. It's not feasible. So anyway, Elizabeth, double check that it looks just like this.
Pretty identical.
Okie dokie. Well, guess what? We're going to hit enter and actually get an answer. And you tell me what you get.
I got 17.2368, and then there's a list.
A bunch of nonsense decimals after that.
Yeah.
Okay. So I just pulled this in. Now, on your problem, does it tell you to round?
To the nearest 10.
That's right. So let's take a look here at this answer. 17.23. So do I need to round up or is it just 17.2?
It's just 17.2 because the 3 isn't bigger than 5.
So we think that the answer is 17.2. All that work led us to this simple number, 17.2.
Yeah. You want me to enter it in and see if it's right?
Let's do it.
All right. It is correct.
All right.
Okay, on to Jonathan's.
Yes.
My turn.
Your turn, sir.
My turn.
You have been very patient. Thank you.
I'm gonna work it out with you guys if you don't mind.
Sure. So, Jonathan,
Now work it. Oh.
Jonathan, you are presented with a situation that is slightly different than Elizabeth's because, well, actually, it's not any different. Structurally, do you know what is your first step, sir?
Do I let's distribute PEMDAS?
Not yet. So right now,
Not yet.
yeah, right now, you have 3,710 multiplied by 0.99 raised to the power of 0.37x minus 1. We need to get rid of the 3,710.
So you subtract the side.
I can't subtract it because right now it is connected to the parentheses with multiplication. So I have to do the inverse operation of multiplication. What's the opposite of multiplication?
Can I get him?
Wait, I don't know if he's Jonathan. Did you drop off, bud?
Well, I'm still here.
Okay, so let me give you a boost. We're going to divide both sides by 3,710. Now, we're not actually going to do that. We're just going to write it.
Yes, sir.
So now, yeah, exactly. Too much work. So now I have 2,600 over.
Oh man,
Yeah, buffering.
Oh,
there it
hopefully
goes.
it'll catch up now.
Yeah, just give it a second.
You know, I know what's doing this too. It's the fact that I put it on ultra low latency. Shouldn't have done that. That's what's causing the problems. Anyway, so I've got 2,600 over 3710.
Alright.
Did you write that?
So basically now
Hang on. What you need to do is reload your browser, okay? And then it'll catch up.
Oh, there it goes.
Everybody watching should reload their browsers, and then you'll be caught up. When it buffers like that, just reload the stream. Okay, so I've got 2,600 over 3710 equals 0.99. Okay, right in parentheses, raised to the power of 0.37x minus 1. Okay, Jonathan, the next step is to take the natural log of both sides. So I'll have ln on the left and ln on the right.
I'll be right back.
Okay.
Wait for me. I can catch.
Okay, Jonathan, so now what we're going to do is write ln of 2,600 over 3710 equals,
0.99.
nope, this is the power rule. So what we're going to be able to do is bring down the exponent 0.37x minus 1, all in parentheses, multiplied by the natural logarithm of 0.99.
Alright.
I'm back.
Okay. So now, Jonathan, I'm now going to divide both sides of the equation by the natural log of 0.99.
Divide both sides by 0.9.
No, ln of 0.99, yeah.
Oh, I forgot. I keep forgetting the ln.
That's okay. And so now I have the natural logarithm of 2,600 over 3,000. Oh, man. I can't do this. I just can't do this. You know what I should do? I tell you what I should do. This would only take me 4 minutes. No, it would only take me 4 minutes. I could leave the live stream up. All right. It would be easier to do it this way than to kill the stream. Leave the live stream up, get in my car, and drive to the school, and it wouldn't buffer. So let me see if let me fight my way through this problem. Okay, let's get it done, and then when we're done with this problem, it should have unbuffered at this point. The
It's back to buffering.
Back to buffering. Okay. Okay. You know what I'm going to do, guys? Just do this for me. Everybody just chill. All right? Just chill for a second, and I will be back. I'll be back online in like 5 minutes, okay? I'm going to leave everything running, and I'm going to write, okay, driving to new location. Okay, so if that comes back online, just ignore it. Okay, so I'll be back as soon as I can. Okay.
Come here.
What the?
I'm talking to my mom.
I know.
This. I want to solve some of these things while Mr. Morelli's gone. Oh wait, are you back, Mr. Morelli?
Yeah, it says he's back. There we go. There we go.
Oh, okay. Never mind.
Yes. Yeah, I can hear you.
But I guess he can't. Yeah, I know. Oh, there you are.
Yo.
Oh.
Okay. So there's two people watching right now.
So you can like see what kind of headset it is, because they're really good for talking and stuff like that. There's from really.
All right. Now everybody can hear me. Hello. Sorry for the delay, ladies and gentlemen, but we are if the thing buffers at this point, I don't know what to tell you because we're at the school. So it is. Oh, okay. Okay, cool. So, Jonathan, where we left off approximately 10 minutes ago, we were rewriting the previous line where we took the ln of 2600 over 3710. Now what? Okay, there it goes. Okay. I guess this is the night for computer glitches, ladies and gentlemen. Sorry. And that's all divided by the natural log of 0.99. Okay. So that's going to be equal to 0.37x minus 1. Now what do we do? That's right. We're going to add 1 to both sides of the equation. Okay. Great. No latency issues right now. Knock on wood. So now we're going to have to rewrite all this because Jonathan's problem is one step more complicated than Elizabeth's was. So I have 1 plus, then I have ln, open parentheses, 2600 over 3710 all over the ln of 0.99. Okay. Okay, so now we just have to divide both sides by 0.37. Now here's how you should do that, okay? You're going to multiply both sides. Okay, instead of dividing by 0.37, you're going to multiply both sides by 1 over 0.37. That's it. It's the reciprocal. Yeah. Okay. And now on the right side of the equation, I can cancel out those 0.37s. Okay. So this is our task. We're going to have x equals, and then we have to type in, pardon me, this entire crazy thing. It'll be interesting, challenging, probably challenging to our patience, but we'll type it in here. And you know, this is one of those where if this is, hey Sheridan. Okay, so now Jonathan, the first thing we're going to do is hit alpha y equals enter and put 1 over 0.37. Okay, multiply that by open parentheses 1 plus alpha y equals enter ln alpha y equals enter 2600 over 3710. Oops. Nice. Okay. Over ln of 0.99. And then we're going to close that parentheses out. So do you see this huge? We are. So is this what you think we should have? It looks just like what we wrote, right? So amazingly, Jonathan, this is what they wanted you to do. So hit enter. Hit enter. And you're going to get a number. So we got a number. And that number was 98.3. Does it want to round to the nearest tenth? So we'll say that x is approximately equal to 98.3. Now, Sheridan, Elizabeth, Jonathan, if this is correct, I want you to know that I packed up all my stuff and I drove back to the school to get back on this computer just so I could solve this problem. And that is how dedicated I was to solving this problem. If it's correct, I am literally going to climb the walls and run around on the top of the school building. Yes, sir. Oh, it's right. Oh my gosh. Oh. Ah! Oh my gosh. Oh man. I can honestly say at this point that I have never worked harder to finish a math problem in my entire life. Okay. Yes, ma'am. Are you ready to give me a unique ID number? Oh. Oh, okay. Okay, hold on, Sheridan. Don't use voice chat to do this with me. Let me take a second. And Elizabeth, what would you like to work on next? Did I just lose everybody? Oh man. Okay. I thought okay. So Sheridan, hang on a second. Let me try to figure out what's going on with your account, okay? Here, Sheridan, I'm gonna open up a remind with you. Give me just a moment, please. Sure, absolutely. Absolutely we can. That would be a good trio. Mm-hmm. So, well, I want you to do as many as you can. Okay, Sheridan, can you respond to that remind? Okay. No. Yeah, yes. At westwoodisd.net. Are you putting the entire email address? Okay, hang on. I want you to type your lunch code into remind, not into Discord, and definitely not into the live chat. Type it into remind. Okay. What'd you hear? Okay, Sheridan, check your remind. Okay, let's see if that solved your problem. And now, Elizabeth, what is your unique ID number? Oh, how cool. All right, this will be a good one. So here is the table that we're given in 0239. So this problem absolutely requires that you use a graphing calculator or Desmos. Let me ask you guys, how would you like me to solve this? In the graphing calculator or in Desmos? Desmos? Okay. Desmos? Okay. So, and Sheridan, did it work? Okay. So this is number 239. Okay, so here's the information we're given. We are given this X and Y table, and we're given 0, 1, 2, and 3. In the X column, in the Y column, we're given 2, 8, 32, and 128. If you guys don't mind, I would very much like to show both methods, the calculator and Desmos, because I can just tell you, because I know what I'm going to have to show you, that some of you will really easily catch on to the calculator version of this better, and others, and you might find the Desmos a little bit new, which might translate to confusing. Okay, so if that's okay, what's the problem? Okay, Sheridan, hold up one second. Let me get to you. Okay, Elizabeth, Jonathan, hold on. I'll get to you next, okay? So everybody focus on this table because you all need to know how to do this. So we're on the calculator, okay? And we're going to hit Stat, Edit. So we've done this a million times, right? We're going to put in 0, enter, 1, enter, 2, enter, 3, enter. Yep. So 2 down, 8 down, 32 down, 128 down. Okay. So here's my data, and we are now going to hit Stat and go over to the Calc menu, but do not go to LinReg because this is exponential regression. Watch this. If we go all the way down and go down, we see EXPReg hidden beneath the bottom of the menu as number 0. So yeah, there's all kinds of stuff that you probably have never seen before. But we're going to use EXPReg, okay? Because this is exponential regression. And then it's exactly the same process as it was for linear regression. You just enter through the menus, and then it gives you an equation, and it tells you what A and B are. Okay? So hold on. Let me pull this data into our OneNote so we can actually take a look at it. And then we'll write our equation, okay? So we're just going to write y equals ab to the x power. That is the standard form of an exponential equation. So now we'll just write y equals and then replace a with 2, and we'll put 4 inside of parentheses. Okay, and we'll put an x right here. That's it. That's exactly it. Now I got to troubleshoot Sheridan's situation here. Did you get that right? Okay. All righty. Okay, understand. So Sheridan, were you ever able to log in to the best of your knowledge? Okay. Wah wah. Okay, let me yes, you do. I'm sure you're right. I'm sure it's something on my side. I'm going to check your account here. We will do it. We'll do it. Manage students. Sheridan. There you are. Wow. Wait, you have 3,000 emails in your Westwood? Oh, okay. Okay, I'm going to try. Okay, Sheridan. I would like you to try again, please. Okay, Elizabeth, are we moving on to the next one? All right. Is this the accompanying table shows the value of a car over time? Okay, so right. So for this one, what I'm going to do, give me a second. You guys are going to see the screen go dark because I actually need to show Elizabeth's problem on the screen, but I don't want to show her name. So let me put the screen dark and then pull it up and hide her name, and then I'll show the problem, okay? Yeah. Are you Well, I just logged in under your account. Okay, so I'm about to show the screen again. Here we go. Everybody see this? Sheridan, did you get in? No. Okay. So you keep working on that. I'm just going to talk to Elizabeth for a second. The accompanying table shows the value of a car over time that was purchased for $18,100, where X is years and Y is the value of the car in dollars. Write an exponential regression equation for this set of data, rounding all coefficients to the nearest hundredth. Using this equation, determine the value of the car to the nearest cent after 11 years. Okay, sounds hard. It isn't. It's basically we're going to do the same thing that we just did, only we have to use the DeltaMath calculator. Okay? Because if we use the TI, it's going to give us a slightly wrong, like slightly different answer. We're talking by less than 1,000th of a percent, but the thing will count it wrong. So what we're going to do is click this Copy Values for Calculator button, okay? And then click Open Statistics Calculator. And then click Paste Values. And it's going to paste all the values from your problem into the calculator. Okay? And now go click Edit under here, Main Menu, Edit Lists. Click this drop-down box and then click Calc Menu. And then under Sub Menu, click on EXP You can choose to turn the diagnostics on or off. I'll turn them on so you can see what the output is. Okay? So this is the output. And Elizabeth, you tell me if your output looks the same as this. Looks like that? Okay, so if we were to write an equation and round everything to the nearest hundredth, what we would write is y equals 18512.05. You have to round that 4 up. Open parentheses, 0.82, close parentheses, raised to the power x. Do you agree? Okay, so let's go back to the problem here. Yeah, we're going to type y equals 18512 dot 05, open parentheses, 0.82. Okay, here I'm just typing in here. Okay, close parentheses, shift 6 to the power of x. So here is the regression equation. And I'll zoom in on it in a second. There we go. Is that what yours looks like? Okay, so we're not ready yet because now it wants to know what happens after 11 years. Okay? So what we need to do is boot up the, get the TI going and go to y equals. Make sure there's nothing written there. Here's what we're going to do. We're going to type it in just like it appeared. 18512.05, open parentheses, 0.82, close parentheses, raised to the power of x. Make it look just like this. Okay, now hit second graph. Scroll down to where x is 11. And then hit the right arrow until you've highlighted this number. That is the answer, 2086.44. So go back to DeltaMath and type 2086.44. Well, let's double check that. No, because you round to the nearest cent. Very, yeah, I hope that's not, let's see if it's right or not. Well, believe me, this guy might. Yay! Okay, it is your turn. Hold on, Jonathan. It's going to be much easier if you just tell me the unique ID. Okay, Jonathan, hang on 1 second, bud. Okay, here we go. So this is Jonathan. It's here's what it is. He's in solving exponential equations, and he is in exponential equations with common base level 1. Exponential EQNs common base level 1 in parentheses. Okay. Number 294, Jonathan. And Jonathan, your problem is given as 4 to the negative 2 power equals 16 to the x minus 2 power. Okay? Now, it said something about common base. These are the bases. Do they look common to you? What if yes, Elizabeth has got the intuition. You said it looks like they could be. What do you mean by that? Ooh, that's very interesting. That is very going down to 2. You know what? Going down to 2 that would be super challenging, but very interesting. So here's what I want to do. No, let's do it. Let's keep it simple, okay? So here's what I want to do. I want to rewrite the left side just like it is, 4 to the negative 2 power. And then you guys tell me if you understand what I'm about to do here. I'm going to write 16 as a perfect square, which would be 4 squared. 4 to the power of 2 in parentheses, itself raised to the x minus 2 power. Okay? Now we're going to apply the power rule, ladies and gentlemen. Okay? And we're going to multiply x minus 2 times 2. So now I've got 4 to the negative 2 power equals 4 to the, and watch this, to the 2 open parentheses x minus 2 power. Now wait a minute. So now do the bases look like they're the same? Yes. So when they are the same, and only when they are the same, you can cancel them and set the exponents equal to one another. So negative 2 equals 2 open parentheses x minus 2 close parentheses. Next step, divide both sides by 2. Oh no. Yeah, they're gone. The exponents are over. Elizabeth, I'll show you, if you give me your problem next, I'll show you what is happening in the background. Okay? It's going to be simple. Okay, so maybe not. So now, what is negative 2 over 2? What does that reduce to? negative 1 equals x menos dos. So now we would add 2. So what is negative 1 plus 2? Positive 1. Oh my gosh. Now wait a minute. If x equals 1, I am personally going to run for mayor and build a Chick-fil-A in front of everyone's house so they each have their own Chick-fil-A. What? Is it right? Yay! Yeah. I'm sorry, guys. Yeah. Okay, now, okay, I'm going to make a prediction. I'm going to predict here that I'm going to get Elizabeth's problem right. Okay? If I don't get it right, I will resign. Okay. One of, just kidding. I'm just kidding. No, I'm just playing with you. Okay, so Elizabeth, you are in the same section on level 1. Got it. Okay. So this is number 261 for Elizabeth. Here we go. Ooh, this is interesting. 125 raised to the power of 3x minus 4 equals 625 raised to the negative 3. Now, let me ask you guys a question. What do you think we're eventually going to be able to get this thing down to? Think smaller. 5. So 5 to what power is 125? Think about 3. I knew Jonathan was going to be good at this. I knew it. I said in my head, Jonathan is going to be good at this. So we're going to rewrite 125 as 5 cubed raised to the power of 3x minus 4. Now, Jonathan, to what power would I need to raise 5 to make it be 625? He's a genius. Guys, ladies and gentlemen, give him a round of applause. Give him a round of applause. You see why he won the calculator, ladies and gentlemen? Do you see why he won the calculator? So 5 times 5 times 5 times 5 equals 625. So was that Nick? Hey, Nick. 5 to the 4th power raised to the negative 3rd. Okay, so now Elizabeth. Let's make sure Elizabeth understands how we arrived at where we're at right now. Okay. Right. So now what I'm going to do is apply the power rule to both sides of the equation here and multiply these two together. So we're not going to actually perform the multiplication. We're just going to say 5 raised to the power of 3, open parentheses, 3x minus 4, close parentheses, equals 5. Okay, raised to the power of 4. Well, I guess we could multiply 4 times negative 3, right? We could just do negative 12. Okay. Okay. So now that hold on. So Elizabeth, do you just want me to, you could jump off the boat. Okay. You could pull the parachute and cancel the 5s and you could set the equation you could set the exponent equation, the exponent expression on the left equal to the exponent expression on the right and solve for x. But would you like to see what's happening in the background? Okay, I'm so glad you said that. We are now going to take the natural logarithm of both sides of the equation. Oh, this is going to be cool because you're going to see why this special rule exists for the equations with the same base. So we did this before. We did harder problems than this before. So what's going to happen now, guys, is this 3 open parentheses 3x minus 4, this whole thing comes down. Okay, and it's multiplied by ln of 5. And that is set equal to negative 12 multiplied by ln of 5. Now watch this. I now have an ln of 5 on both sides of my equation, so I can divide it out of both sides of my equation. Ln of 5, ln of 5. Now watch this. You ready? Cancel, 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 cancel. Pretty cool, right? So now we've arrived where we were before, okay? We just have 3, open parentheses, 3x minus 4 equals negative 12. Now, do you see why I didn't distribute the 3? Because now I'm going to be able to divide both sides by 3. Okay? On the left side, I can cancel the 3's out, and I've got 3x minus 4, and that's equal to negative 12 divided by 3. What's that? Negative 4. Okay, and Elizabeth, you can solve this from here. Mm-hmm. So you want to add 4 to both sides, which is the correct thing to do. Canceling out the 4 on both sides. How dare you? Now you have, it's a joke, you have 3x equals 0. Now, what do you, hold on. Let's let Elizabeth follow through with her plan. What would you like to do now? Oh, yes, you can. Yes, you can. It's still legal, okay? You have not broken any math laws. You can't divide by 0, but you can divide 0 by anything. What is 0 divided by 3? Don't. A 0. So, if this is really that complicated, look at what all the work we did. If all that work led us to x equals 0, ladies and gentlemen, I will personally purchase an F-16, fly it into outer space, land it on the moon, and hook up to a satellite on my Surface Pro and teach the math class from the lunar surface. Oh, no. Oh, wow. Oh, oh. Just put in 0. All right. Ah! Oh, you got to go? Okay. All right. See you tomorrow. All right. Bye. Okay, Sheridan. Did you ever get into Delta? Wait, you're waiting for something to download. Are you on your phone or are you on a computer? Is your sister there? The one that I know. Wait, it could be the younger one. Anybody that's got a phone. Is anyone else there that has a phone? Could we go locate one of those people and get their phone for a second and go to DeltaMath.com on their phone? Okay. All right. Jonathan, what are you working on right now, man? Or is there anyone else in the chat that needs help? Because I've definitely helped. Okay, who is that? Nick? Okay. Nick, what's your unique ID? Oh, because you were waiting so long. Sorry, bro. Oh. I'm sorry to hear that, Nick. Listen, you missed the most insane tech support IT nightmare. It was just buffering nonstop. And basically we had a whole bunch of people on this chat, and then it buffered so much that I feel like we lost pretty much the entire audience. And it was a total nightmare. And so I drove right in the middle of helping Jonathan with the problem. I just left the live stream running on YouTube, and I just literally threw everything in my car, and I put on some flip-flops and just drove like at top speed to the school. And now I'm at the school. And we were back doing the problem in less than 10 minutes. So here, if you guys don't believe me, here's the sound of that basketball behind my desk. Right, man. Yeah. Okay, Nick, well, you let me know what your problem is. 0270. Okay. And which assignment are you working on right now, Nick? Cool. Oh, really? Okay, so Nick, give me that unique ID again. 270? 0270. Okay. Okay, so Sheridan, I want you to attempt to log into DeltaMath on whatever phone you obtained while I help Nick with this problem. And I did log out and get a new browser going on a different computer, and I logged in on your account. So I'm thinking it's something on your side, but I'm not saying it is. I'm not saying that is the case, but it might be. But either way, Sheridan, if you can't log in, don't worry about deadlines and whatnot. Just kind of pay attention to the live stream, and you can make, for you, Sheridan, because you can't log in. We've been troubleshooting it for an hour. If you can't get logged in, just copy down what we're doing here on this live stream, and that'll substitute for your homework since you have a tech support issue. Okay. That way you don't feel like you're not accomplishing anything here. So let's do this one with Nick, and this will be one for you as well, Sheridan. So I'm going to involve you in the problem. So what we're asked to do in this problem is solve for x to the nearest tenth. That's not how you spell near. Yes, it is. And here's what they give us. 3.8 equals 1.1 raised to the power of x minus 5. Okay? Now, Sheridan, do you remember the letters of the special thing that we learned how to do this week? No, do you remember the here, I'm going to show you the calculator, okay? Look at this calculator and tell me what letters we learned, what button did we learn how to press this week? It's Ellen. All right. She got it. Okay, so what we're going to do, no, you're not. We are going to put both sides of the equation in huge parentheses. And we are going to take the ln of both sides of the equation. Okay? So on the left side, I have the ln of 3.8, and that is equal to, and here's the whole purpose that we did that, Sheridan. Do you see this exponent x minus 5? Well, now I'm able to bring it down and set it next to my problem. So I can write x minus 5 in big letters and numbers, put it in parentheses. Go ahead. ln of 1.1. You did it. Okay, now we're almost done. We just have to do two things. So 2 steps from being finished. So let me let Sheridan think about this for a second. What does this big red dot mean? Okay. Alrighty. So what would be the opposite? So I'm going to divide both sides of this equation. The other one, the other ln. Yes, we are going to divide both sides, very good, of the equation by the ln of 1.1. Okay? Now this is really important. I can cancel out this stuff on the right side. And now I have x minus 5. And then I'm kind of writing backwards now, equals, and then I've got the ln of 3.8 over the ln of 1.1. And now there's just one more step. I need to reverse this. To get x by itself. Yeah, wait, I was waiting for you to say something. Okay. So right now on the right side of the equation, we have x minus 5. I want x to be by itself. Yes, you do. Yeah. So we're going to add 5 to both sides of the equation. And on the right side, that means I can cancel out the negative 5 plus 5. All right. Now I just have x by itself on the right side. And on the left side, I have 5 plus the ln of 3.8 over the ln of 1.1. So here's the thing we need to do. We need to put the entire left side of the equation into the graphing calculator. Okay? Now I'm going to move this around a little bit. Let me get out of here. And so now I'm just going to type this in, Sheridan, just like it looks. 5 plus alpha y equals, enter, ln 3.8 over ln 1.1. Enter. Okay, we get 19.0069 something or other. Now it wants us to round it to the nearest tenth. So do I need to round anything up, or is it already good? So if I'm rounding to the nearest tenth, I would write 19.0. Well, I actually think that DeltaMath is going to be interested in those significant digits. Yeah, I would do the 0.0. I would hate for you to get it wrong because of that. So, Nick, that's it. Okay. Yay. You guys need to take a break, or are you okay? Okay. I will keep going. Oh, yeah, that one where you had to raise it to the power. I knew you'd be good at that, man. Of course. That's why we're here, man. Gotcha. Oh, cool. I'm excited about this. Okay, actually, what I want to do here, guys, I'm going to have to go dark on the screen because I'm going to pull his account up here on the screen. So you're going to see darkness, but I'm still here. The stream is still live. We're not buffering, and we did not lose the stream. Does it look black for you guys? Good. That's what I need. Sheridan, did you ever get logged in by chance? See, I actually need to. Is your mom home? Okay, because I actually need to. I'll just have to help you on Monday, I guess, because I need it, or I'll call tomorrow Because are you going to be at the game? No. You're going to be at the softball game? Okay, then I'll definitely see you there, and I'll definitely help you, okay, tomorrow. Here. Why? Well, I am personally not concerned because I know you're going to be really good. What position do you play? Ooh, which one? Because that would be like way different. Wow. Okay. That's a big job. I'm excited for you. Okay, can you see the screen now? Okay, so this is Nick number 268. We're going to call this Nick and Sheridan. Okay. Because this is also Sheridan's problem. Am I spelling your name right? A-N? Okay, here we go. Element X decays radioactively with a half-life of 12 minutes. I understand why you think this is hard. It sounds really hard. Oh, man. Like, the quantum particles created a wormhole in space, and you fell into the event horizon, and now you're at the center of a black hole. Okay. It just sounds insane. Okay. So let's just keep reading. If there are 890 grams of element X, how long to the nearest tenth of a minute would it take the element to decay to? I'm just thinking about how Nick said he was completely blown away by this. Oh man. Okay. I'm losing it, man. Okay. You're like, losing? How about lost? So let's start labeling some stuff with human language. 111 grams is the future value. Yeah, that's right. Okay. So that means that we're going to write 111 on the left side of the equation. Now, what was the starting value? Okay. So I'm going to try to color code this for you. And for this one, because I know that multiple people are watching this, I want to write what it is. So 890 is the starting value. And that's going to be A. Okay. So that's the starting value, 890, and A. So we'll write here 890. Okay. And it's telling us what the decay rate is. The decay rate, the letter, so we need to look at the basic equation is y equals A, open parentheses, B, close parentheses, to the x. Okay? So right now we know that y equals 111. We know that A equals 890. And we know that B equals 0.5. Okay? But we need to also remember that B equals 1 minus the rate of decay. So if 1 minus the rate of decay is 0.5, what was the rate of decay? Think about it as percents, okay? So 0.5 as a percent is 50%. That means every 12 minutes, this element loses 50% of its value. So the decay rate would be 50% every 12 minutes, okay? I'm going to let you guys catch up there. So in this problem, we'll finish writing what we have. So we have here 0.5, okay, raised to the t over, and now we need to look for this h value. So this little h, let me get a different color. This little h right here is 12 minutes. All right, so for h, we're going to put 12. Okay? Everybody comfortable with where we're at right now? See, what we're looking for is t, okay? And t is time. All right? So we want to know the time. How long does it take? So now let me rewrite this problem so it looks just like a problem that we've already done 1,000 of. 111 equals 890 multiplied by 0.5 raised to the power of t over 12. Okay? So now try, if you can, to forget about the words and just act like the only thing that exists is this math problem and solve it for t. What would be your first step to solving it? Okay. Let me see if I'm interpreting what you're saying. You want me to divide both sides by 890. Okay. And so once I do that, I will have the ability to cancel out the 890s on the right side of the equal sign. Everybody comfortable with this? All right. Yeah. And so we're actually learning some like chemistry, physics, some physical chemistry here. This is pretty cool. Decay of elements. Who knew we would get to play with this stuff? Okay, so now I have 111. I guarantee you guys this is going to be useful in your chemistry classes and also in your physics classes. 111 over 890 equals 0.5 raised to the power of t over 12. So that's where we're at right now. So I'll open the floor up to Jonathan, Nick, and Sheridan, and anyone else that's on the call. What would I do now? And I'll tell you, the answer has something to do with forests. A forest. Was that Jasmine? Hey, what's up? Yes. What is the forest made out of? Okay, and what do we make wood into? What else? What do you put in your fireplace? Keep thinking of other words for that. Hey! Oh! We're going to take the natural log of both sides. Oh, man. Oops. That was exciting. That was something. So here's the benefit of doing all that, okay? I'm now able to take the t over 12 and I get to bring it down. Okay. So what I'm going to write now is t over 12. Okay. Oh, not yet. So times the natural log of 0.5. Okay, we're 2 steps from being done. We got to get the t by itself, but right now t is being divided by 12, and t divided by 12 is being multiplied by the ln of 0.5. So I have to go in reverse order and get rid of the ln of 0.5 before I can undivide the t. That's right, sir. So let me let Nick answer me because this is his problem. What do I do, Nick? Oh, that's right. Yes, that's what we're going to do. Divide by the ln. It does. I heard Jasmine say 0.5. And now these cancel out. And now I have to rewrite everything. The ln of 111 over 890. Hold up. Divided by, not yet, divided by the ln of 0.5 equals t divided by 12. And now I have one step to do. No, the variable has to be by itself. No, Nick, you have to undivide. How do you undivide? That's right, sir. So we are going to multiply both sides of this equation by 12 over 1. Okay. So the reason I did that is so I can cancel out these 12s. And now we've arrived at that hallowed moment where we have the variable isolated. And so here's what's going to go in the calculator. 12 times the ln of 111 over 890 over the ln of 0.5. Now, what that is going to give you when you put this in the TI, and we'll do it in a second, but I just want to let you know. Look at the work that we did. Okay? See all that work? And we did all this work to find out how long it's going to take it to decay from 890 to 111 grams. And I can just tell you that you will do this math if you take chemistry at the higher levels, or you take chemistry in college, or if you take physics in college. Okay? So you will absolutely do this problem like this, and you will astonish your teacher. Be like, Miss, who teaches chemistry here? You would astonish Miss May and Miss Basic if you showed them that you can do this. Okay? Like, I would definitely show them this homework problem once we get it and tell them, explain what you figured out how to do. Because this is really useful in chemistry. Can you see how it could be really useful? You now know how to find out how long it takes radioactive elements to decay. That's crazy. I mean, that you can do that. You're only in 9th grade. So let's figure it out. Let's get a number to go with T. T's going to be some number in minutes. So let's just plug this into the calculator, which for some reason I decided to turn off. Okay. So what we're going to do is type alpha y equals enter. Okay. And we're going to type in 12 ln alpha y equals enter. 111 over 890. Close those parentheses over the ln of 0.5. Okay? Do you see how this looks exactly like what we figured out? All right. Now, did you notice I didn't put a multiplication between the 12 and the ln? It's going to understand that it multiplies, okay? But you could put a multiplication symbol and it would just do the same thing. So are we all ready to press enter? 3, 2, 1, enter. Okay, so what we got is 36.038. Well, that's huge. So does it want it to the nearest tenth? So it said here to the nearest tenth of a minute. So what we can say is, I'm going to, just because for this one problem, I want to explain. So what I'm going to say is, it takes, because this is what they would want you to write this out in chemistry. It takes element X 36.0 minutes to decay from 700 to 1. Wait a minute. I'm sorry. I'm using the wrong. I've got the numbers wrong. Hang on. I'm writing it wrong. To decay from 890 to 111 grams. Okay. Now, you know why this could be really important to know how to do? What if this element happened to be plutonium or uranium? See, it would be really nice to know how long it took it to decay, because that might be the amount of time that you have to get out of the nuclear reactor. Okay? So this is like a hugely useful and interesting problem. So this is what you're going to put into delta, though. What a cool problem. I'm so glad we got to do that one. Oh, yeah? Let's see if we got this one right first. Was it right? Oh, I was waiting. I was waiting for you to tell me. Oh, I was just waiting. I don't know. Yeah, you guys think I have the key or something. I have no idea. No, that's great. Yeah. Oh, great. Yeah, no, Nick was already, he's like moved on to 3 problems later. We're all just sitting here in total silence. This is so cool. Hey, make sure you screenshot this right here and show Miss Basic and Miss May what you learned. Because you could literally take any. They could give you some elements like real chemistry to work with. Like, because you just learned. Have y'all learned about the radioactive elements in Mr. Carroll's class yet? So you could just take radioactive elements, and you could find out what the half-life of the elements are, and we could do a real problem. Okay, you could show this to Mr. Carroll too, and ask him to give you ask him what the half-life of uranium or plutonium is, and he'll tell you, and then we could take that, okay, and we could actually work this out for something real. All right, so who wants to do another problem? That was really fun. Who is me? Jasmine? All right, bro. Peace. Jasmine, what is your unique ID? Are you on Delta? It should be saying it in huge writing, bold font, unique ID, and then a 4-digit number. Hang on, let me just log in under your account. Yeah, Sheridan. Uranium. And the other one is plutonium. Uranium and plutonium. Okay. And I think you would want to ask him for the isotope of uranium called uranium-238. Okay. Have y'all learned about isotopes yet? Oh, okay. Just ask him about, show him this and tell him Morelli wants to know the half-life of uranium-238. Because we would need the half-life, the radioactive half. We can actually look it up. Look, let me show you. Okay, this is just too cool to not do. Okay, before you guys lose interest in this, let's look up half-life of uranium-238. Okay, wow. Wow. You want to do the math problem with that one? See, but you could replace element X decays radioactively with the half-life of 4.5 billion years. If there are 890 grams of uranium-238, how long to the nearest tenth of a billion years would it take the element to decay to 111 grams? Now, we could do it, okay? We could do it. But yes. Hey, we can actually do it very easily, okay? Here, look. So notice that down here in this final part, this was the half-life, okay? This was the future value, and this was the initial value or starting value or present value, okay? So all we would have to do to figure this problem out, if we wanted to do this problem for uranium-238, is we would need to change that 12 to be 4.5 billion. Well, we would have to figure out 4.5 billion years in minutes. And we could figure that out very easily, guys. Here, look. So I've got 4 billion, 500 million, and then 0, 0, 0, 0, 0, 0. Okay? That's 4.5 billion written out. Okay, so let's figure out how many minutes there are in a year. Let's say, how many minutes are there in an hour? So 60 minutes in 1 hour. And how many hours are there in a day? And then Sheridan, how many days are there in a normal year? Yes. So we're about to find out how many minutes there are in a year. 525,600 minutes. Okay? Now, what we're going to do now is we're going to convert 4.5 billion years into minutes by multiplying 4.5 billion times 525,600. Okay? I just did it. It's on the screen. Okay, so it's 10 to the 15th. Okay, so it means that I'll have 2.3652. Okay, times 10. Yeah. You did? Wait a minute. Let me see if you got that right. Wait a minute. So here's what we're going to do. We're going to go delete this 12, okay? And we're going to replace it with that. Y'all see what I did here? Okay? So that's all I had to change in order to figure this out. Here's the answer. So here, let me write it out for you, okay? Pull this into, this was too interesting not to do. You guys are cool. You guys are cool for doing this. So now what we're going to do is move this decimal place over 15 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I need to add 0, 0, 0, 0, 0, 0. Okay. And here's a comma. Here's a comma. here's a comma, here's a comma, and here's a comma. So this is hundreds, this is hundreds, this is thousands, this is millions, billions, trillions, and quadrillions. So it would take 7 quadrillion, 103 trillion, 276 billion, 634 million minutes for 890 grams of uranium 238 to decay to 111 grams. Okay? That's a lot of minutes. Okay, so let's find out how many years that is. It's really easy. Okay? Just divide it by this number we found before. Right? Because we're take the answer and divide by the number of minutes in a year. Okay? 525,600. So it's gonna take like 1 trillion years for that to do. Wait a minute. So this is years. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here's hundreds, thousands, millions, billions. Okay, so that's 13 billion, 514 million, 605,000, 470 years. Okay? Now, let me show you one last cool thing. So that remember this 13.5 billion number, okay? That's how many years it would take to decay. So let's go back to the browser and let's type in right here, age of the universe. You ready? In years. Oh! So basically, if you started with 890 grams of uranium 238 back at the birth of the universe 13.8 billion years ago, then you would still have some left today, because it would be like 100, it would be like 111 grams would still be left. Now, guys, this is why people are so scared of nuclear war. Okay, because if we set off nuclear bombs that contain uranium-238, then it could take billions of years for all of it to go away. We basically could destroy the Earth if we set off all those bombs. Because look how long it takes for it to kind of like, you could think of radioactive decay as like it evaporates, It would take another 13 billion years for it to evaporate. So we don't want to wait around that long. Anyway, I'm glad that you guys took that little fun journey with me. So here's the good news, guys. So people that are watching this chat right now, you have now done several problems on this solving exponential equations, right? And here's all you have to do for me, okay? If you just come back to this chat and work with me for another 3 hours, either on Saturday or Sunday, whatever we end up getting done, that will be good enough, right? Because you shouldn't, I mean, the purpose of these chats is that if you're working with me and learning, then that's enough, because that would be like 6 hours. All right. I'm asking you, you were on for 3 hours tonight, and I'm going to do 3 hours tomorrow and 3 hours on Sunday. And so if you can find just one of those two to attend, then I feel like that's plenty of math work for the weekend. 6 hours, right? That's a lot of work. Okay. But anyway, so what I want you to do is, if you are really struggling and you just don't understand how to do it on your own, you can substitute your participation on these live streams for actually completing all the homework. Now, for Jonathan, okay, Jonathan, you need to complete the homework, and I want to make sure I help you enough that you can complete the homework. All right? And even if that means that we have to do an extra live stream just for you to get through all your problems, I want to make sure that you get through them. And Jasmine, Jasmine, and anyone else, Sheridan, Nick, Emma, who else was on earlier? Evan, Elizabeth, anybody who is interested in getting really good at this, you should do all of them. Okay? But by showing me all this effort tonight, if you can show me a little bit more this weekend, you can just pick your day, which day you're going to do it, and just hop on. You don't really have to stay the whole 3 hours. Like, just stay long enough to do like 2 or 3 problems with me. So we practice a little bit. And if you can do that, then I feel like that you've learned enough about exponentials so that we can move on. All right. Because I don't need you to master this. I don't need you to be able to sit here on your own and just work out all these hard problems. I really just wanted to kind of expose it to you, and I feel like we got a good foundation tonight and exposure to a lot of different kinds of problems involving exponents, exponential equations. Okay. I thought it was very interesting as well. So on this high note, I would want to end this because we're going out on a real high note here. Does that sound okay? Because I think a lot of you are going to be at the PlayStation tomorrow. So y'all need to get to bed. Okay. All righty. Well, thank you. Well, okay. So here's the deal, Jonathan. I'm going to end the stream, but I'll start the stream back up when I get home if you still want to work problems, okay? But I just can't sit at this school anymore. I'm scared. I'm scared because I'm the only person here. Yes, it's creepy. Yeah. Yeah, I'm honestly scared. So no, I'm not. But it is kind of creepy because my voice is echoing like all around the building, and so yeah. So let me pack up my stuff and get out of here, and then when I get back home, I'll restart the stream, and we'll see, Jonathan, if the latency issue kicks in and it's buffering, then we'll just stop. Okay. But you want to do it tomorrow, or do you want to work on it? Do you want to work on it later? Do you want to stop now? Okay, good. Then we'll stop now, and we won't even try to start it up later. We'll just all take some rest, okay? Yeah. Okay, guys. Okay. Hey, listen, thank you all so much for joining this live stream. And I want to thank everybody for being here. And you guys all have a great evening and get some good rest. Okay? Okay, bye. Bye.